Good morning friends. After the discussion of the alpha decay, now the next decay process is the emission of beta particle, that means the beta decay. The question is that explain the beta decay process, or how does a radioactive nucleus emit the beta particles even if there are no beta particles in the nucleus. Emission of the beta particles, that means either the electron or the positron are emitted from the nucleus. But already we have the information about the nucleus. Inside the nucleus, the positively charged proton and charged neutron are present. Electron and positron are not present inside the nucleus. Why? During the nuclear process, as a beta emission or the beta decay, or during the beta decay process, the electron or the positron are emitted. Okay. Now, this question you also ask like this minute. Why does the radioactive nuclei not change during the beta emission? During the beta emission, why the radioactive nucleus does not change? So these are the questions we are going to discuss in beta decay topic. Now, what is the beta decay process? The process in which the nucleus spontaneously emits an electron, that is known as the beta minus decay, or if it emits the positron, that is known as the beta plus decay. This process is known as the beta decay. Again, the process in which the nucleus spontaneously emits an electron or positron, this process is known as the beta decay. Clear? Again, the definition of the beta decay, the process in which the nucleus spontaneously emits either electron or the positron. Such process is known as the beta decay. The emission of electron in beta minus decay is accompanied by the emission of an anti-neutrino, while in beta plus decay process, the neutrino is emitted. That means during the beta emission, when the electron is emitted, not only the electron is emitted, with electron the anti-neutrino is also emitted. And also, during the beta decay process, when the positron is emitted, with this positron the neutrino is also emitted. That means in beta decay process, when the electrons are emitted, this process is beta minus decay. With the electron, anti-neutrino, that is denoted by this symbol, is also emitted. And during the beta plus decay process, that means during the emission of the positron, the neutrino is also emitted. Neutrino is also emitted. Now, the neutrino have the very small approximate zero mass compared to the electrons. They have the weak interaction with the other particles. Therefore, it is very difficult to detect them. What is the characteristic of neutrino? Neutrino has the very small mass, even zero mass compared to the electron. They have the weak interaction with the other particles. And due to that reason, less mass and very weak interaction with the other particles, it is very difficult to detect this neutrino. Neutrino is not easily detected. The neutrinos and antineutrinos can penetrate the large quantity matter, even the Earth, without any interaction. Now, the neutrino and antineutrino can penetrate the large quantity of matter, even the Earth, without any interaction. Now, we discuss the beta decay process in two parts, beta minus decay and beta plus decay. Beta minus decay, that means the electron are emitted with the electron, antineutrino, and beta plus decay, that means the positron is emitted with positron, the neutron is also emitted. Now first we take the beta minus decay process. In beta minus decay, the atomic mass number of the daughter nucleus remains same. Atomic mass does not change. But the atomic number of daughter nucleus is increased by 1, that of the parent's element. Again, during the beta minus decay, the atomic mass number of daughter nucleus does not change, while the atomic number of daughter element is increased by 1, that of parent's nucleus. The general equation of the beta minus decay is xza convert into the yz plus 1a plus electron, that means the beta minus electron is minus 1 is 0 plus neutrino. Again, the general equation of the beta minus decay is xza convert into the yz plus 1a plus electron plus neutrino, where the x is parent's nucleus, y is daughter nucleus, and minus 1 is 0, that is the beta minus particle, and that is our electron. Right, there is the empty particle of the electron, that is the empty neutrino. The mass of the empty neutrino is very less, that means the no mass, but it has the spin is equal to plus or minus 1 by 2. Empty neutrino is the empty particle of electron. Frequently asked in 1 marks question. The empty particle of electron is empty neutrino, right? And the symbol of the empty neutrino is gamma bar. Okay. Now, example of beta minus decay is the phosphorus 1532 convert into the sulfur 1632 plus electron plus empty neutrino. Again, the example of beta minus decay is phosphorus 1532 convert into the sulfur 1632 plus electron plus empty neutrino. The half-life of this is 14.3 days. Right? Again, we repeat the beta minus decay. In beta minus decay, the atomic mass number of the daughter element remains same, but the atomic number is increased by 1, that of parent's element, or the parent's nucleus. The equation of the beta minus decay is xza convert into the yz plus 1a plus electron plus empty neutrino. There is a parent element having the atomic number z, atomic mass number a. Daughter element is y, atomic number is increased by 1, atomic mass is remained unchanged. And the electron plus empty neutrino are emits. Clear? The general equation of the beta minus decay, that means the emission of electron during the beta decay process, is phosphorus 1532 convert into the sulfur 1632 plus electron plus empty neutrino. Half-life of this process is 14.3 days. 14.3 days. Now, the next is the beta decay, beta plus decay. Beta plus decay, that means the position is emitted. In beta plus decay, atomic mass number of the daughter nucleus remain unchanged, or they remain same. But the atomic number of the daughter element is decreased by 1. That means the Z is decreased by 1, A is remain unchanged. Again, during the beta plus decay, atomic mass number of daughter nucleus is remain unchanged, while atomic number is decreased by 1, that of parent's nucleus. The general equation of beta plus decay is xza convert into the yz minus 1a plus position plus neutrino. Clear? Again, xza convert into the yz minus 1a plus position plus neutrino, where the x is the parent nucleus Y is proton nucleus and plus 1 is 0. There is a beta plus, that means the position, and there is the empty particle of position, that is the neutrino. Therefore, the neutrino is the empty particle of the position. While the empty particle of the electron is anti-neutrino, while the empty particle of the position is neutrino. Now, the equation of the beta plus decay is sodium 1122 convert into the neon 1022 plus position plus neutrino. Half-life is 2.6 years. Again, the beta plus decay. In beta plus decay, the atomic mass number of the daughter nucleus remain unchanged. That means they remain same. But atomic number is decreased by 1, that of parent nucleus. And the general equation is XZA convert into the Y, Z minus 1A plus position plus neutrino. And the equation of the beta decay is sodium 1122 convert into the neon 1022 plus position plus neutrino. Okay? So that is the beta decay process, and also we discussed about that. In which condition the electrons are emitted and in which condition the positrons are emitted. And what is the basic nuclear process during the emission of beta? Now, during the beta decay process, why, or in which circumstances the electron, or in which circumstances the position are emitted, right? Okay. In beta decay, a neutron is converted into a proton, or a proton is converted into a neutron. The masses of the proton and neutron are equal, right? Therefore, the atomic mass number of the nuclei A is equal to Z plus N does not change. Our question is that during the beta decay process, why the atomic mass number does not change? Right? So here the result is that in beta decay process, either the neutron is converted into the proton or proton is converted into the neutron. Right? And also the mass of the proton and neutron are almost equal. Therefore, the atomic mass of the nuclei A is equal to Z plus N does not change. That is, does not change. Clear? Therefore, during the beta decay process, the atomic mass number does not change. Now the next question is that explain the basic nuclear process by equation in beta decay. That means, during the beta decay process, in which circumstances the electrons are emitted or positrons are emitted. For that purpose, the basic nuclear process during the beta decay process is that if an unstable nucleus has an extra neutron, if an unstable nucleus has an extra neutron, so far, to obtain the stability, a neutron is converted into the proton. Neutron is converted into the proton. Again, if an unstable nucleus has an extra neutron, for the stability of the nucleus, this neutron is converted into the proton. And this equation is represented by the neutron converts into the proton plus electron plus anti-neutrino. That is also written as the neutron N01 convert into the proton P11 plus electron -10 plus neutrino. Sometimes this question you also ask for the 1 marks objective question. Any blank is given. Suppose here the blank is given. So here the neutron is converted into the proton. At that time the electron and anti-neutrino are emitted. Again, if an unstable nucleus has an extra neutron, so far its stability, a neutron is converted into the proton that is represented by the equation neutron converted into the proton plus electron plus anti-neutrino. So neutron 0 N1 plus proton 1 P1 or the 1H1 plus electron -1 is 0 plus anti-neutrino. And that is known as the beta minus decay process or the emission of the electron. This process is known as beta minus decay process or the emission of electron during the beta decay. Now, how the positron is emitted during the beta decay process? Now, if an unstable nucleus has an extra proton, so far its stability, a proton is converted into the neutron. If an unstable nucleus has an extra proton, so proton is converted into the neutron. So that is given by the equation proton P converted into the neutron. At that time, the positron and neutrino are emitted. Positron and neutrino is emitted. Therefore, proton P11 converted into the neutron 01 plus positron plus 1 is 0 plus neutrino. So keep in mind that any nuclear reaction, the both sides the number of Z and also A must be 1. So here 1 1, here Z is 0, 1 minus 1 0. Here Z is 1, P and A is also 1, both sides. Again, if an unstable nucleus have an extra proton, this proton is converted into the neutron, is represented by the equation proton is converted into the neutron plus positron plus neutrino. Thus, the positron is emitted and this process is called as the beta plus decay. That is called as the beta plus decay. Right? Now the next is explain. Now the next question is to explain the gamma decay. What is the gamma decay? During the alpha decay and beta decay, that means during the alpha decay, the helium nucleus are emitted, and also during the beta decay, either the electron or the positron are emitted. Now, when the nucleus, radioactive nucleus is disintegrated by emission of the gamma rays, such process is known as the gamma decay. Again, the definition of the gamma decay is that the process of emission of gamma rays during disintegration of the radioactive nucleus is known as the gamma decay. Again, the definition, the process of emission of gamma rays during disintegration of radioactive nucleus is known as gamma decay. Gamma rays has no mass and no charge. So, atomic number and atomic mass number of daughter nucleus does not change, that remains same as of parent nucleus. Again, the gamma rays has no mass, no charge. Thus, during the gamma decay, whatever the daughter nucleus is formed, having the same atomic mass and same atomic number, that of parent nucleus. That means the Z in A does not change, remain constant. Z in A constant. The general equation of the gamma decay is XZA converted into the XZA plus gamma S. Gamma S has no mass, no charge. Okay. So initially the parent element or the parent nucleus is in excited state, and newly formed nucleus, that is the daughter nucleus, that is in ground state, its energy is less than the parent nucleus. But the atomic mass number and atomic number are same as the parent nucleus. There is no change in Z and A, but the energy is changed. When a nucleus is in excited state, spontaneously decays to its ground state or lower energy state. A photon with the energy equal to the difference between the two energy levels is emitted, and this is known as the gamma decay. Again, when a nucleus in an excited state spontaneously decays to its ground state or lower energy state. When the nucleus is spontaneously decayed to ground state or the other lower energy state, during this, the photon of energy equal to the difference between two energy levels is emitted, and that is known as the gamma decay. That is known as the gamma decay. A gamma is emitted when alpha or beta decay results into a daughter nucleus in an excited state. This daughter nucleus returns to the ground state by single photon transition or successive transition. In which condition the gamma rays are emitted? Okay, a gamma ray is emitted when a alpha decay or the beta decay results into a daughter nucleus. This daughter nucleus is in excited state. This daughter nucleus returns to either the ground state or the other energy levels by the single photon transition or the successive transition. During this single transition from higher energy level to the ground state or successive transition to return to the ground state, so the gamma rays of different energy are emitted. Again, the gamma ray is emitted when alpha or the beta decay results into the daughter element, which is in excited state. This daughter nucleus returns to the ground state by the single photon transition or successive transition. Now in figure, when the cobalt 2760 emits the beta minus particle or the beta minus decay take place, convert into the nickel 2860, which is in excited state. This excited state are held in two successive transitions and emits the gamma rays of energies 1.17 MeV and also 1.33 MeV energy. Again, here in figure, when the nucleus cobalt 2760 emits the beta minus decay or the beta minus particle, converts into the nickel 2860, which is in excited state. Right? These excited states are held in two successive transitions and emits the gamma rays of 1.17 MeV energy and also 1.33 MeV energy. Clear? Again, what is the gamma decay, or they explain the gamma decay? The process of emission of the gamma rays during disintegration of radioactive nucleus is known as the gamma decay. Right? When the nucleus is disintegrated, during this disintegration process, the gamma rays are emitted. This process is known as the gamma decay. Gamma rays has the no mass and no charge. Therefore, the daughter nucleus has the atomic mass number and atomic number are same as that of parent nucleus. That means the Z and A remain constant, there is no change. The general equation of the gamma decay is XZA in excited state convert into the XZA, that is in ground state, and gamma rays are emitted as the no mass and no charge. But here the energy of the daughter nucleus is decreased or the less than the parent nucleus. When a nucleus is in excited state, the spontaneously decays to its ground state or lower energy state. During this retransition, a proton with the energy equal to the difference between the two energy levels is emitted, and this is known as the gamma decay. That is known as the gamma decay. Gamma rays emitted when the alpha decay or the beta decay results in a daughter element. Right? And this daughter nucleus is in an excited state, and this daughter nucleus returns to the ground state by the single photon transition or successive transition. Here the one example of the cobalt converted into the nickel by emission of the beta minus decay. In figure, when the cobalt 2760 emits the beta minus particle, converts into nickel 2860, and which is in excited state. These excited states are held in two successive transitions and emits the gamma rays of energies 1.17 MeV and 1.33 MeV. So this is the gamma decay process.